Hello and welcome back to lllm. Today I will continue to talk about context engineering for AI agents development. If you are building AI agents, you have probably experienced these problems. Your agent forgets important decisions from earlier conversations, it repeats some questions, or it completely fails on complex multi-step tasks even though the model is very capable. But these are not model failures, these are context failures. Because of this, context engineering has become a critical topic nowadays. The major players like lllm, Google, and Anthropic are publishing research about this. lllm's blog post explains how agents need proper context management to maintain state, retrieve relevant information, and make consistent decisions across long interactions. So the key and the core problems is the context window. Large language models have limited context window, as you know. Even large ones like 200K or 1 million K tokens, everything competes for the space in the window, right? Your system prompt, like instructions, the knowledges, which including the conversation history, retrieved documents, and also the tools include the tools, output, and the intermediate results. As the agent runs longer, the context window fills up, important information gets pushed out, the model loses track of the earlier decisions, and the attention degrades. That the model cannot focus on what matters. This is called context degradation. So like what was said by Anthropic, that the agents often engaged in conversations spanning hundreds of turns, requiring careful context management strategies. That is also because the impact for degradation is very real, like task completion rates drop, the token cost increase because you tried failed tasks, the production reliability is suffering. So good context engineering solves this. It gives you higher task completion rate for complex workflows, better consistency across the long conversations. Like here, the lllm framework gives you 4 buckets: write, select, compress, and isolate to help you implement the context engineering features inside their framework. And the framework from Google called ADK is also giving you the methodology like sessions, memories, and artifacts, and working context as a compiled view, such strategies in their ADK framework. So that means you can implement the context engineering under this mature framework or manually use your deep understanding to build your own mechanisms like token economies, memory architects, and multi-agent patterns. But this creates some barrier for developers who want to build better agents without becoming context engineering experts, and is not preferring such framework to limit their imaginations. So today I will show you a practical solution using skills. So before we get into the detail, let me introduce first about the very important and helpful tools called agent skills, which will be the key to help us to implement the context engineering in our agent development. So the skills concept come from the platforms like Cloud Code or OpenAI's Codex. Skills give the IDE agents awareness of design patterns and methodologies. Instead of manually implementing the context engineering patterns, you activate skills that guide the agent to apply proven techniques during your development. Skills provide structured knowledge about when to apply the specific patterns, how to implement them correctly, what trade-offs to consider, and how to integrate with other patterns, including examples. So this transforms the context engineering from a manual design challenge into a guided development process. Now let me show you a GitHub repository that implements this approach. It's called Agent Skills for Context Engineering. This repository provides a comprehensive set of context engineering skills in standard Markdown format, including the foundation skills like context fundamentals, context degradation, context compression, and the architectural skills like the multi-agent patterns, the memory system, and tool design, and other operational skills like context optimization, evaluation, advanced evaluation, and project development as a development methodology. So as the author describing X account, instead of just offering a library of black box tools, it acts as a meta agent knowledge base. It provides skills that you can feed it to an agent so it understands how to manage its own cognitive resources. So each skills here is compiled into a markdown file, the skills folder, as a skill.md file. Each skill here is synthesized from the technical research documentation the author has already included in its docs and docs folder. So that means these skills are organized not just from a menu development, but instead it has a very strong background from these firmed researchers. So how do we know these skills actually work? To demonstrate the practical impact, I conducted a comparative experiment using Claude 4.5 model in Cursor IDE. So there are 3 experiments that I will show you, including the LLM evaluation system and a project memory system, which is used to test the memory system creation with and without the skills. And also a research assistant, which will be created to test the multi-agent patterns in this research application development, as always, with and without skills. The experiment design is very straightforward, which is to compare the architecture decisions, context management strategies, code patterns, and production readiness. So for the full process flow, we will load the relevant skills into the project rules in the skills test, or skip the skill for baseline creation, and give the same identical prompts to the agent for each task, and let the agent to creation implementation summaries for both versions, and we will compare how skills influence the implementation by looking at the summaries mainly. This controls the comparison reviews how context engineering skills guide the agent automatically, even when using an advanced model like Claude 4.5. Let's examine the 3 cases right now. So first, let's look at how to load these skills into the Cursor IDE. So basically, this kind of generic IDE doesn't support the skill in its released version yet, but it still has a very strong rule definition in its setting. So in the Cursor setting, you will see there is a rule and commands option, and in that option you will find the project and user rules adding area. Let's add the skill as rules to the project by click the adding custom rule. So here you can add a name like context fundamental as a new rule, and then you can find the context fundamental folder in this agent skills for context engineer repository, and the skill MD file you can copy it and paste into the Cursor. If you add the rule with the skill template, and it will goes to the skills category with our skill content, context fundamentals. Okay, so basically the Cursor IDE has already supported, and then you can add more rules into the skills by adding into the rules one by one, and that's it. That's the way to load the rules into your IDE agent. So right now the agent of Cursor has already been equipped with the skill and be aware of how to do the fundamental context engineering into its creation based on your prompt. So here is the result. that I mentioned before about the creation of 3 projects by using very simple prompt with and without skill. And I will not repeat in this video, and we can directly go to this finished project to see the difference. So let's see one by one. The first example is the LLM as a judge task, which will build a system that evaluates the LLM responses, use multiple criteria with structured output. This is the final project. We can directly looking at the implementation summary to understand what's going on in this project. You can see I created with one simple prompt, build a small TypeScript library that acts as an LLM evaluator, LLM as judge, with direct scoring of responses, pairwise comparison, and rubric generation. I repeat this prompt into another plan agent with the same prompt and create another project in different folder to do the summary comparison. So basically both implementations create a TypeScript library that can evaluate AI responses against custom criteria, and each project can do the score responses on configurable skills and provide structured feedback with reasoning and compare multiple responses in the pairwise comparison and generate evaluation rubrics automatically. So let's run this 2 projects to have an idea what's going on here. So let's run the first one in no skill test. It does the direct scoring first by give a simulated prompt and simulated response, and give the criteria and do the evaluations. Okay, the first one is complete. The evaluation including the score in different criteria like accuracy, completeness, and examples, and a summary, and overall score, and a suggestion. So it looks basically good even with no skill, because we use the Claude Opus 4.5 model, which is quite advanced model, which has a lot of context engineer methodology inside already. And this is the comparison with 2 response simulation, and this break down the summary and do the rubric at the end. Now the demo complete. Let's try another one. Scale version. You will see the first example, the direct scoring with chain of thought strategy, which is quite important to make a more context aware output. So the result is very concise but very clear in criterion scores. And you will see the pairwise comparison will be with the bias mitigation. So that's also a very important to make sure the context are being aware to eliminate the bias in the summary. And the rubric generation is additionally with strictness. So when you look back into the source code from the skilled version of direct scoring source code from the no skill, you'll quickly find the difference and advantages that the skill version has been created. For example, in the prompt of the evaluation criteria, the skill version has provided very clear chain of thought instructions, but the no skills ones has not provided. The next demo is the project assistant, which is used to test our memory design skills for the IDE agent. So I used the prompt design a project assistant memory plus context management system for long-running conversations and large projects. Mainly for function demo, don't put too much on UI for front-end stuff. Create it in the folder and at the end write a summary files. So basically I found that by using the Opus 4.5, the memory system design is not so much different between the no skew and with skew. Maybe because it's an advanced model, the memory system designs has already been strong enough to have the context engineering concept. So I will skip this one. You can check these two projects with their memory implementation details for the slightly difference. And we will quickly move to the final but very interesting project, the research assistant. Now let's look at the third task, which is build a research assistant that can research topics and analyze the findings and generate the reports. So like previous examples, I also created this project by a simple prompt here. Create an assistant app that can research a topic on the web, analyze findings, and write a report. So let's see such simple prompt under Opus 4.5, what kind of project it will create with and without skill. So in my complete project, by directly looking at the implementation summary, you'll find in the NoSQL pipeline, it looks like it has the several agents, but basically it's still a research assistant to do all the tasks by only separate the subtasks into different implementation layer, including web researcher, analyzer, and report generator. But when you look at the implementation under skill, you'll find that the architecture is much more complicated, but much more sorted with multi-agent orchestrator. Include a research agent with input, output, and tasks, and analyzer agent and writer agent, equipped with different tools and different instructions for the input and output. And for the content flow, the non-skill project accumulated context through pipeline, but for the multi-agent implementation, the contexts are all isolation between each agent gets cleaned slate. And if for the state management, file system state machine is the key benefits for the multi-agent implementation with the context engineering skill equipped. So let's quickly run the two versions of the research assistant project. For the NoSQL, so let's run Python manpy to analyze the climate change effects on agriculture. So the result is very straightforward. It's doing a search on the web, found 10 results, and do the findings analyzing and do the report generating. And for the skilled one, I created here, it's a node project. We use the same topic to let the multi-agents to do the research. So the process is a little more complex, but the key difference is the internal data flow between the agents and the orchestrator. And this is the final summary. So it's very clear that with this context engineering formatted skill, each agent starts with a very clean context window for the researcher, for the analyzer, for the writer, and no accumulated context from the previous agents. So if a conversation is not necessary, it's not required to deliver to the next agent. And it prevents the lost in the middle effect because the useless information has been eliminated. And each agent can use full context capability for its tasks. That's the result. To wrap up, the context engineering is becoming essential for production agent system. The skills provide a practical way to integrate these patterns into a daily development without requiring deep specialization in every technique. And thanks for this amazing repository, Agent Skills for Context Engineering, we can directly load these skills into our preferred IDE to quickly let our design agent to create context-aware project for us. That's all for today. If you have further questions or ideas, please drop them in the comments below. Thanks for watching. I'll see you in the next video.